Right now, just to show you a video game, the chip in your computer is doing 36 trillion math problems every second. To match that by hand, you'd need 4,400 planets, each packed shoulder to shoulder with people, every single person doing one sum a second. So your graphics card must be some kind of genius. Here's the punchline. It's a total idiot. It just happens to be 10,000 idiots, all being dumb at the exact same time. Meet the GPU. It can't run an app. It can't open a browser. It knows basically one trick. And it does that trick 10,000 times at once. To see why that's brilliant, meet its rival, the CPU, the chip that actually runs your computer. The CPU is a tiny team of geniuses, a dozen of them, each fast, each able to do anything. The GPU is the opposite, a stadium stuffed with 10,000 interns who flunked math. Each one can push exactly 2 buttons, multiply and add. That's the whole skill set. So who wins? Trick question. Hand them one hard, twisty problem. The geniuses win easily. The intern just drools on it. But dump a mountain of identical baby math on them, add these, now do it a million more times. And the geniuses are still rolling up their sleeves while the 10,000 idiots already finished. Here's the secret. A video game isn't one hard problem. It's the same tiny problem, a few million times. Pure idiot food. That hat in the game, it's really just 14,000 dots connected by lines, and every dot is just 3 numbers. How far left, up, and forward it sits. To slide the hat across the room, you add the exact same little number to every single one of those dots. 14,000 dots, one identical instruction. A genius would grind through them one at a time. The GPU does something way dumber and way better. It shouts one order. Everybody, add this to 10,000 interns at once. Each grabs one dot, does the one sum, and the whole hat teleports in a single blink. Now do that for every object on screen. Millions of dots, all moving at the same instant. That's the magic word, parallel. All at once beats one at a time by a mile. So what's actually in there? Crack one open. The whole chip is a square smaller than your fingernail, built from 28 billion microscopic on-off switches. And almost all of it is just interns. Over 10,700 of them, each a tiny calculator we call a core. The one move they're built for? A times B plus C. That's it. Each spends 400,000 switches just to do that single sum blindingly fast. So do the math. 10,000 of these, each doing 2 tiny sums, a multiply and an add, nearly 2 billion times every second. Multiply it all out, and you land right back around 36 trillion. That terrifying number from the start was just this dumb little calculator's spec, said back to you. It's got a fancy name, fused multiply add. But it's just times then plus. Say that at a party and watch people leave. There are 2 specialist idiots too. Tensor cores that crunch whole grids of numbers, that's the AI math, and ray tracing cores that bounce light for shiny reflections. A few of those, a zillion of the basic ones. Now a genuinely funny fact. The expensive card and the cheap card, same chip, identical twins. When they bake these chips, random dust and flaws kill a few interns. Instead of trashing the whole chip, they just fire the broken ones and wall them off. Then they count the survivors and slap on a price. Every intern alive, the top tier card. 16 squads dead, the budget card. Same chip, some idiots just got laid off. But 10,000 interns doing trillions of sums get hungry. No numbers to chew on, and they just sit there idle. So the card carries its own private pantry, the VRAM on the box. When a game loads, it's shoveling the entire scene into this memory so the interns can grab it fast. And it's fed like a cargo ship. Not one little conveyor belt, but 24 cranes dumping data in at once. Nearly 1 trillion bytes a second. Your regular computer memory? It moves maybe 1/20th of that, on one skinny belt. The GPU's appetite is just on a whole other scale. Fun twist, you think computers are all ones and zeros? This memory cheats. It stacks extra voltage levels on each wire to cram in more than just ones and zeros. Speed demons. Here's where it gets bigger than games. Anything that's the same dumb sum a zillion times is idiot food. And it turns out a lot of things are. Bitcoin mining? It's a lottery. The card scribbles 100 million random lottery tickets a second, praying one starts with enough zeros. Brute force guessing, perfect for a crowd of idiots. Although these days, special machines do it thousands of times faster. So mining Bitcoin on a graphics card now is like digging a tunnel with a spoon next to an excavator. Training an AI is just enormous grids of numbers multiplied together over and over. Exactly what those tensor idiots were built for. The thing that renders your game is the thing teaching machines to talk. That's why everyone on Earth is fighting over these cards. The same army of idiots that makes your game pretty is right next door, growing the AI that writes your emails. So the most powerful chip in your computer isn't powerful because it's smart. It's powerful because it's dumb, gloriously, repetitively dumb, times 10,000. A genius solves one hard problem. An army of idiots solves a million easy ones in the time it takes the genius to find a pen. Just a different superpower. So next time a game looks impossibly real, remember what's really happening back there? 10,000 tiny idiots, each doing one sum, screaming done in perfect unison, 60 times a second. So, what would you point this army of idiots at? Prettier games, mining coins, or building the next AI? Tell me below. I'll draw the winner.